Hello and welcome back to the Parallel Thread and R series on learning programming. Now, if you've been following along in this series, you'll know that it's been quite a while since my last video. And the reason for that is that I've been waiting on a new setup which would hopefully make the videos better. We can now do them in 16:9 instead of 16:10, and hopefully editing will be a much nicer experience for me as well. I thought it would arrive much sooner than it did, so the waiting has been much longer than I anticipated. And because of that, I'm starting out a bit earlier with the setup than I would have wanted because I haven't figured out a good placement for my microphone and camera yet. So the quality on the video and audio might be a bit different to how it'll be a bit later because I'm just using the built-in microphone and camera from my new setup, my 2020 iMac. But hopefully it'll make do for now. Soon I will set up my proper microphone and DSLR again so we can continue with that kind of quality on the audio and video. But I think this will be fine for now, so we can continue our series a bit faster than we otherwise could, and that you'll enjoy. This video will be on Lambda Functions, and of course we will address the challenges I gave you last time as well, looking at some possible solutions so you can compare to your own solutions and see if you solved it in a different way or you did the same thing that I'll be showing. I'll be showing two different ways of solving the challenges. One with the tools I gave you last time with loops and conditions, and another way that will use today's topic, namely Lambda Functions. So without any further ado, let's dig into it and look at the challenges first. Alright, so here we are back in the familiar Harbor Town project in BlueJ, just as we know it. And we're going to dig into the Harbor class where I gave you the challenges for last time. So, in order from top to bottom, the first challenge I gave you was this one, the number of blue boats, right? And one way we could have solved this was to say that, let's just remember how this goes because it's been a while. So we had this list in our program named boat, and the boats was just a list of all the boats in the harbor, right? So something we can do is that we can say that our return value, which will be the number of blue boats, is an int, and this is the, let's call it return value, right? And we set that to 0 from the beginning because right now we don't know that there are any blue boats. And we just say for boat in the array of boats. So this is for every element in the list of boats, right? It will be extracted into this name here, boat, which is of type boat. I put that in front of it, right? And then inside of this loop, inside of the body, which we'll get to here, we can do interactions with this boat element, which will be every element in the boats list, right? So you can say for boat in boats, we'll do boat dot, and then there's this little thing in BlueJ where if you hit Control space, you'll get up a list of auto completion. So we can just hit color, and all of this we'll put in an if statement. So that if the boat's color, if boat.color equals, and then we want color dot blue, and then we will increment return value plus plus. We'll close that, and then we'll return value. So there you have one possible solution for the number of blue boats. And once you've solved one of these, I highly encourage you to compile it and go and run the appropriate test in the test class I gave you to see that the solution works. In this case, number of blue boats. You can see this line down here on the left goes green. That means that the test passed successfully. So back to the code, we can go to the next challenge, which is where we want an array of all the blue boats returned. And very similar to the last one, actually, what we can do is that we can loop over all the boats and pick out a list of every time we get a blue one. So this time we'll just say our return value will be a list of boat, which we'll just call, again, return value, just to keep it simple. In a proper application, we might choose names that are better appropriate or more appropriate to what we do, but return value also sort of works in this case because it's just a temporary storage of what we'll return. And this will be an array list. Oh, actually, because the function expects not just a list, but an actual array list, we should change this to be an array list. Though a more appropriate solution would actually be to just change the function declaration to use a list, which is more flexible in the long run, but I made this with array list, so that's what you should return. We'll make a new array list, boom, like that. And then we'll say for, just like last time, boat in boats. And then we'll do if boat.color equals. Remember that one equal sign is an assignment, two equal signs is a Boolean comparison. And then we'll do color.blue. And this is just exactly the same as last time, except with a list as the return value instead of last time where we used an integer. So now what we can do is we can say return value dot, and then there's a function called add, as you can see, where we add a boat. So we'll add a boat. This will be the boat we're at in the looping over all the elements. Add a semicolon to that, close that, and then we'll return the return value. And just like last time, we'll compile that, and we'll right click on the test block here, and we'll run test list of blue boats. See that it passes down here, and we can move on to the final challenge, which is this one, first person or first owner between 20 and 30, which is this person object we want. And in this case, we don't need to have a temporary return value stored along the way, because all we need to do is loop over the boats again for a boat in the list of boats. And what we want to do in here this time is say that actually let's do a bit clean code here, and instead of doing the extraction of the owner every time, in both comparisons, both checking that he is over 20 and below 30, we will extract, actually let's extract the age of the person. So we'll extract an integer called age of owner, which will be equal to boat dot, and I think it's called owner, isn't it? Oh, that was not capital B, of course. Boat dot owner, owner, or get owner was what it's called, of course. Dot, and then it's probably called get age, right? It was just called age. All right then, like that. And then, now that we've done that, once we do the comparison, we can just say if age of owner less than, actually let's do greater than 20. You can decide here, I think I set it to greater than equal 20, and age of owner less than equal 30. I think I made it less than and greater than equal, and not just less than greater than strictly. It's been too long, so I didn't look at it, but I'm assuming this was right. If it isn't, we'll see it in the test case afterwards, because that's the great thing about having test cases. You can verify your code meets the specification that you want it to along the way. So we'll say if this condition is true on the elements as we loop through them, because we are only returning the first person between these ages, what we can just do is we can directly return the owner in here. So we'll say boat.getOwner, and like that, of course. And then we'll need to close these off. Bam. And if we don't find the owner inside this, we'll return null. And as always, we go back, compile, and I'm using Command K to compile. It might be Control K on Windows and Linux. And we can test first owner. And it passes, so it was indeed greater than and less than equal, and not strictly greater than less than. So that's one possible way of solving these challenges, and the way that I expect that you've probably done if you did the challenges, using control flow with for loops and these conditions with if. Now I'm going to show you another way of solving these solutions, which will be using today's subject of lambdas. And these are very powerful and let us express these things very concisely. So let's take the number of blue boats here and delete all of this. And we are now going to solve this whole thing, get all the number of blue boats in a single expression. Yes, one line of code, that's all. So what we'll be doing is this. We will say, indentation. I thought there was something wrong. There we go. So what we'll say is that we'll say the boats array that we have. There is a function on this called stream. You can see it there. And stream is a special kind of thing in Java. It's a funny little data structure where we sort of almost get a built-in loop for us. So in the stream, we'll say filter, which you can see there. And filter takes a predicate, right? So what we'll get is we'll get this element, boat B, which it again comes from this stream, right? This is the element in our stream, the boat B. And then we can do some condition in here that will filter out elements that don't fit this condition. So we can say boat B dot color equals color dot blue. Now we have a stream of only the blue boats. Now what we can do is we can say that count. This will give us how many boats are in this whole stream. I'll just say bam. And this whole thing will become a long, which is like an integer, except it can represent bigger values. So to make this function accept it, because it accepts only an integer, we'll say we'll cast it all, as it's called, convert it all to an integer, and then we'll return that. And hopefully I wrote that code correctly. We can see, yes, it compiles, and we can check that the code still works by running the number of blue boats, and we get a green line. Fantastic. So look how much code we left out here. We don't have any loops, strictly speaking, and we don't have any conditions, strictly speaking. This is purely one line. Now, what people usually do when they work with stream like this is that they will take all these breakups where it's a dot, and move it down the line and indent it as well. So put it in. This, some would argue, when you have a lot of these conditions, makes it more readable, and it doesn't change anything from the perspective of the compiler. The code will work just the same. So you could do it this way as well, which is a little bit prettier. You don't need as much width on the display to read the code. So what in this is actually the lambda, right? Because I was saying that the subject of today was lambda functions. Well, it's this thing in here, the parameter for the filter function. A lambda is sort of like an anonymous function in a way, because if you think about this, what this is, right? It's a function that takes a boat as an argument, boat B. This arrow indicates now we begin the function. And what the function does, right, is it returns the Boolean value of b.color equals b.blue. And for every element in our stream, filter will be called, filter will call our function, I should say, checking each element against this condition and using the Boolean value that this implicitly returns to check if an element should be in the list. So let's have a look at the next challenge here, where we need to return an array list of boats. So we can probably tell that this starts out very similar to last time, because we're filtering against only the blue boats. So let's start by getting a stream of these boats. We'll jump down to the next line and do the indentation thing from the beginning. And here we're doing filter. And again, we're filtering on a B. We're doing type inferencing here. We're just saying you can guess that it's a boat. And actually we can, when we only have one possible thing, we can remove the parentheses around it as well. And type inference just means that instead of us saying this is a boat, it's just obvious that it's a boat because it comes from a stream of boats. So we don't have to specify that B is a boat. And b.color equals color.blue. Oh, almost at the, there we go. And then we can, now we can't use the count thing anymore because we're not reducing it down to a single primitive variable. What we want instead is to make a collection, an array list of these things, right? Gather all of these elements up in the stream into one array list. And for that, there is a method called collect, which you can give any form of like collection method, but in this case, we want to collect it into an array list. And there is a thing called collectors.toCollection, which we can say array list : new. This will make us a new array list with this collection from this stream. Now, this collect this thing also has a method called toList, which will give you an arbitrary list, right? It's not an array list, it's some list. And behind the scenes, I'm pretty sure it is an array list, but it's the interface of a list, so that doesn't show. So if you do toList instead, and you don't, this doesn't take an array list as parameter, it takes nothing, but I'm just not going to leave that for now. This wouldn't be something you could return directly because it wouldn't be an array list, it would be an abstract list. But if we changed it to return a list instead of an array list, we could do this. And something you can do is you can give an array list a toList as its initializations parameter. So you can give an array list a list and it'll return it fine. But in this case, using the toCollection thing is more clean. So we'll do that instead. toCollection, because we know we're returning an array list. Now, if you get an error that this collectors thing, collectors.toCollection can't be found, it's because at the top I've imported java.util.stream.star, which is the package in which it resides. Now I want to say one thing right here before we continue. all of this stuff, like the syntax for collect collection or collectors to collection, all that, it's not something that you need to remember by heart. When you've done this a million times, you probably will remember it by heart, but if it's not a function you use all the time, nobody expects you to remember this stuff, right? You're not a bad programmer or an imposter just because you don't remember this kind of thing. I looked it up just before we did this because I couldn't remember the exact syntax, if it was a parameter to the toList thing that made it an array list, or it was this to collection thing. All programmers look up things all the time. What's important is not really the exact syntax of this sort of thing. You will pick up speed and remember a lot of it, but you don't need to remember all of it. What's important is that you know the idea of what you want to achieve, right? In this case, we knew that we wanted to gather up our elements into an array list, and that gives you the search terms you need to find this line online. And that's the important thing. It's the idea of the algorithms, not the code itself, right? The rest you can Google your way to. Someone online put it once that the boss asks, if you just sit on Google all the time, what do we pay you for? And it was if you just copy code from Stack Exchange all the time, what are we paying you for? And the programmer looks back and says, because we know what to copy and what not to, right? So that's sort of key here. You're not an imposter just because you copy code or read along or need to look shit up. We do it all the time. So lastly, let's look at our last challenge with a lambda, and then after that we'll look at lambdas in a more abstract way and talk about them more generally. So in this one we need to return a person, and let's get rid of all of this again and say return, because we know we're going to return it after essentially one line, even if it does pick up multiple lines. And again, we'll do the boats.stream. And this is sort of a functional way of working as well. So if you're into functional programming, or you've heard the term functional programming, working with streams in this way is something you often do in functional programs. So again, what we want to do here is we want to get the first owner between 20 and 30, right? So let's start by filtering for that. And say, again, we get a boat out as our input to this because it's a stream of boats. So we can say b.getOwner dot age greater than or equal 20 and b.getOwner as a method dot age less than or equal 30. That is our filter. So now what we have is a stream of boats where the owner is between the ages of 20 and 30. What we actually want is the person object, the owner. So what we do is we use a map which takes one of these boats and can sort of convert our whole stream into something different. So it can map a boat object to something else. In this case, we map each boat to the owner inside the stream, which means we now have a stream of person objects. And then we can just, dot find first, right? This gets us what's known as an optional, as you can see here, because this stream might not contain any of these objects if all of the owners are not between the ages of 20 and 30. We need a or else property, which specifies what happens if we cannot find it first, and we just get a null, and that compiles. We can go back here. There we go. And we can run all our tests, and as you can see, we now have a green bar. Everything works. Now let's talk more generally about these lambdas, because they're actually quite cool. Java sadly has a clunky syntax for them in a lot of cases, because Java as a language wasn't really made with these in mind. Java originally didn't have these at all. They came in Java 8. Other languages that we'll look at later when we start developing iOS apps, Swift in particular, has a much cleaner syntax for working with lambdas and closures. But we'll look at Java for now because it's what I'm teaching here in the beginning. And what I want you to know about these functions is that they allow you to have program code come in dynamically. So let's go to the top here, and we're going to need another import to define these things as types. So up here we'll say import java dot, I think it's in the core, it might be in the util library again. Let's see if that, no, it's in util. Okay, so let's add util here. There we go, that works. And look at just one of these because there's many of them, but one type of lambda in Java is the supplier, which takes a T, meaning generic. You can put in here what kind of type of supplier it is. Let's make a double supplier named give me a number, right? And what this one is, right? It's a function that takes no argument and produces a double. Let's just say new double 1.4. Bam. So this may look like a very, very clunky way of just giving back 1.4. A double, by the way, is like a bigger floating point number, so it's a number with decimals, right? But what this allows us to do is actually very, very flexible, right? Because this can be any type of function that returns a double, right? This could be a big function or it could be a small function. It doesn't really matter. It's a function of any kind, a method that returns a double and takes no arguments. Right, there's also something called a consumer, which takes one argument, and I think that one doesn't return anything. Yeah, it doesn't return anything. It's just it takes one argument and does something. And there's a by consumer, which takes two arguments and all sorts. You can read about them in the Java docs. So I strongly recommend that if you have any questions, look it up on the Java docs because lots of information can be found there. You can just look up this package java.util.function online. In the Java docs, and you can find all sorts of things about these and many more. So let's have a short look at why this might be clever, this way of doing these, right? Because if we define a function here that returns an int, let's just call it makes double into int, and this one takes this supplier thing of a double, right? Let's just call it function to be a bit more clear about what it is, or lambda actually, let's call it lambda, right? And put it inside curly braces because we're defining a function. What we can say is we can return, and then we can call this lambda, right? But we don't call it normal way because Java is weird. So what we actually do is we say get, which calls the function, and then we get the int value of it, right? And this might just look like a normal thing that converts a double into an integer. And again, integer, whole number, double, decimal number. But what's really clever here is this can dynamically execute code not inside this function, right? So this function just converts this value. But this value itself, when we call the get here, could do all sorts of things, and not just returning this double, but it could go over the network and find this double value from some server or whatever. It doesn't really matter how it gets us this value, but it's some kind of code that gets executed to give us this value, right? It's not just the value itself. And in composing code together, that is a really powerful tool. So that's the core of Lambdas. When we get to iOS programming, I assure you, you'll see a lot more of this because it's a very, very powerful tool in the Swift programming language. In Java, it's of course also a powerful tool, but the syntax is very clunky around it, so you might not see it used as often outside of working with streams, where, as you can see, it can give us very succinct and nice code that does a lot in short steps, right? Because that's what all of these things are, right? This whole thing here is an inline lambda, right? We could have defined this whole thing the way we did up here as its type and use the variable name to use it. But this here is an anonymous version of the lambda. We just write out the lambda right here where we use it. And this bit of code is then sent to the filter function, which uses our bit of code inside of itself. So it's code running code. It's really cool in that sense. So that's our video for today about Lambdas. I hope you enjoyed it as always. And I'm very sorry about the image quality maybe being a bit lower than you're used to from the webcam. I mean, from the screen, it should be much better. And the same goes for the audio quality. I assure you, audio quality will go back up again when I get my microphone set up and we continue with this series on learning programming. But I still hope you got something out of it, and I know that this topic might have been a bit more difficult to get your head around than the past topics we've gone over, and that a lot of the code might have just sort of come out of nowhere and been a bit of a mess, a jumble to keep track of, because there are so many new concepts all at once. But when you break things down, all of the individual components we talked about today aren't actually that difficult to grasp. It's just that all of them are used at once. So I think that once you get familiar with each individual part of it all, you'll quickly come to sort of understand the way all of it plays together. So I urge you to just keep playing around with streams, read online when you get stuck. You can write in the comment section and I'll make sure to respond to you if you have any questions. As always, I'll have the code here in a link below on my website. You can download this, look through it at your own speed. There are no challenges this week or this lesson, but maybe I'll make some for the next tutorial, which will be coming faster than this one came relative to the last. So, thank you for watching. Hit the like button, hit subscribe, write a comment, all that jazz, and see you in the next one.